Okay, so EMI, for EMI, what are things we are studying in this one? Okay, yeah, by the way, any doubt in this chapter, previous chapter, current electricity? Any of you? Jafar? Is that clear, that chapter? Sure. So we can move to EMI. It's another most important chapter, EMI and alternate current. Pravalika, what about you?
Yes, sir.
Are you clear with the chapter, current electricity?
Yes, sir.
Okay, then. Okay, what about Sai Charan? Okay. See. Okay, in electromagnetic induction, first thing we are going to discuss about Faraday's law. In that first law, let's have one roundup of this chapter, then we can start. First law. What does first law says? When magnetic flux linked with circuit it change EMF. Change an EMF. Second law says what? Induced EMF is proportional to rate of change. That is E equals to d phi by dt. And for n turns, we will introduce n here. Here minus indicates it's minus, so negative side. So n d phi by dt. Induce EMF. So direction is done by Fleming's right hand rule. What is magnetic flux? Phi equals to BA. Without this one, yeah. Without vector sign, cos theta. What does it says? The number of magnetic field lines passing in particular area or unit area. Yes, very good. In that we have Lenz's law. So what is the Lenz's law? Direction of induced EMF, it will be always opposes cause. The opposite is the cause, to which or how it is produced, it's just opposite the direction. It will be opposite the direction. And what else we studied in this chapter? Right and thumb rule, sorry, right hand rule, Fleming's radial rules. You can say I equals to NBA omega t sine. I wrote in small, sine omega t divided by r. We missed something. If we differentiate, it will be one more omega. A omega sine omega t. Now okay. What else we have? Motional EMI due to translatory motion these are just basic things like formulas and all that. Now if we say like that, E equals to BVL. Now what is E, what is B, what is L? E is EMF, B is magnetic field as usual, L is length, V is velocity. So sin theta is angle between them. Induced current I equals to BVL cos theta by R. What is eddy current? It's just cos component. Because if it is VL sine 90 minus theta, it will give you cos theta. They both are this angle. That side is cos theta. Yeah. What is eddy current? So I'm just doing roundup of this chapter, like so that we can recall everything what you have studied. Anyone remember what is eddy current? It is just like induced current. Like what happened when magnetic flux is linked or with conductor, whatever it's changed. That is just induced current, similar type. Now what is the application? Any application? Yeah, less power loss. That means electric power meter. Then where you can use braking, magnetic braking, etc. Yes. What is inductance? What is inductance? Do you remember? It is same just a property of electric current. L equals to N phi by I. So self-inductance equals to minus L di by dt. So unit of L, Weber per ampere or Henry. Self done, mutual. Mutual inductance M equals to phi by I. If it is n numbers, number of turns, it will be n phi by I. So M I equals to n phi. We can say that. Okay, so what is the use of EMI? Where we'll use? Generator or dynamo. It works on this AC generator dynamo works on principle of EMI. So this was just a quick roundup of this chapter. So tomorrow we'll start our actual topic and we'll do some numerical. Did you see that? Did you wrote everything? This roundup of this chapter. This chapter. First we'll discuss few topics, then we'll do numericals on this chapter, EMI. Problems or whatever exam questions. Okay, everyone done? Is anyone writing? Jafar, Praneeth, Pravalika?
So 1 minute.
Yeah. You want me to scroll down? What's up?
So the last line.
So
Got it.
okay, but what I'm saying, every chapter it should be written like this. Okay, those who are like starting now for 12th standard, so have a habit of this one. Like what I wrote full chapter with formulas and all small from basic. This way you should write in one small page as a notebook. I ask you to do, right? So this way we have covered actually whole chapter this way. But this you can do after you complete your chapter. So every chapter should be one page, not more than that. One page is also so big, it should be half page also, like this. Okay, guys, if you have habit of this one, then it will be easier during your exam or whatever it is. If you're not started yet, do it now. If you're done, if you're doing it, it's good, because I'm saying this since so many months. I lost the count of how many months I'm saying the same thing.